So these pages are additional practice problems. So in this case, the beginning, we're starting with what looks like side splitter theorem, right? So you have to look and see what they're asking you for. So if we're looking for the entire sides, then we know that we're going to have to set up a proportion. So we're given that 8 over 12 is going to be, so let's see, what do they call that? I think that's an S. So we'll say S over H, right? Because we're comparing the horizontal to the horizontal and the height to the height. So now, if they tell us the height of the tree is 30, we can solve for the length of the shadow by cross multiplying. So 12S is equal to 240. Divide by 12, we get that S is equal to 20 meters. So given triangle AED is a dilation, so that tells me I have similar shapes. Centered at point A, what is the scale factor of triangle ACB if triangle ACB is the pre-image of triangle AED? So very similar to the one above. So we start with 3 compared to 6. Oh, I'm actually skipping a step. So here, we're looking for the scale factor. The new length of AB is 5. So the new over original is 5 over our original 3, which if you want to write as a decimal would be 1.6 repeating. Now if we look for the value of BC, 3 over 6 is equal to 5 over x. So x should be equal to 10. And we could also check this because if we do 6 times 5 over 3, which is our scale factor, you will also get 10. So now again, we're looking at side splitter. So if I want to find the value of x, so here, so we have top over sort of like the cutoff. So we have 3x minus 5 over 10 is equal to, if this is 8, so then this is 20, is equal to 20 over 8. We have 200 equals 24x minus 40. 24x is equal to 240. And we'll get that x is equal to 10. So again, this is using the side splitter. So if we scroll, if you look back, it was after angle bisector. Yeah, so it is back to this relationship, right? So you're looking at the top versus the cutoff, 1, and then the top versus the cutoff, 2. Okay, so we'll keep going. So this right here, since this is telling us that we have the angle bisector theorem, so what we'll do is we'll look back at our notes, look for angle bisector. Angle bisector was before side splitter. So the angle bisector theorem tells us that, so BD, which is our bottom piece over our other side, is going to be proportional to the bottom piece and the other side, excuse me, of our new triangle. So if we look, so we have 1 and 2. Let me turn on Do Not Disturb. And we have 1 and 2. So I know that 7 over 28 must be equal to x over 20 by the angle bisector theorem. So 28x is equal to 140. So then 140 divided by 28. X is equal to 5, but I want to know the entire length, so 7 plus 5, which gives me 12. So now, if we're looking, so we are looking for the side splitter again. So let's see. So if this is 20, and that's 36, this is 16. So this piece would be 45 minus 5x. So 5x over 45 minus 5x is equal to 20 over 16. I'm doing the top overcut. So we're going to cross multiply. 20 times 45 gives me 900 minus 100x equals 5 times 16, 80x. So I'm going to move this over. I'll get a 180x on this side, 900. I'm going to do 900 divided by 180 to get that x is equal to 5. So this is angle bisector. So again, we'll first look at the pink. So we have 10 over 2x minus 5. So if this whole thing is 24, this piece would be 14 is equal to 14 over 21. Cross multiply. 28x minus 5 times 14, which is 70, is equal to 210. Add 70 to both sides first. 28x equals 280. So we can see that when I divide by 28, x will be equal to 10. So here we're not given a picture, so the first thing I'm going to do is draw a picture. The sides of a triangle are 7, 9, and 13. An angle bisector meets the side of length 9. So the angle bisector hits length 9 and divides it into x and y. Find the length of x and y. So again, we can only solve with one variable at a time. So we're going to rewrite y as 9 minus x to set up our proportion. So we have x over 7 is equal to 9 minus x over 13. 63 minus 7x is equal to 13x when we cross multiply. Add 7x to both sides, we get 20x. Divide both sides by 20. We get 3.15. So then that is x. So then y is minus 3.15, which is 5.85. So again, angle bisector, setting up a proportion. So we have 28 as one piece over x. So we do 54 minus 28 to find the other bottom, which is 26, and then 26 over x minus 5. Cross multiply, 28x minus 140 equals 26x. If I move the 28x over, negative 140 is equal to negative 2x. So then x is equal to 70. The perimeter of PQR is 94 units, and QS bisects angle PQR. Find PS and PR. So the first thing that we know is that the perimeter is 94. So if the perimeter is 94, so then 94 is equal to 29.2 plus 22.4 plus PR. So I can use this to solve. So 94 minus 29.2 minus 22.4. So PR is equal to 42.4. So that's the entire thing. So if we call one piece x, we can call the other piece 42.4 minus x and use that to solve. So let's look. X over 22.4 equals 42.4 minus x over 29.2. Cross multiply. 42.4 times 22.4 gives me 949.76 minus 22.4x equals 29.2x. Move the x over. So we have 29.2 plus 22.4. 51.6x equals 949.76. So 949.76 divided by 51.6. X is equal to about 18.4. So if one piece is 18.4, we subtract from our total to get the other piece is 24.